Hello friends, I welcome you to the ongoing Six Sigma journey, and if you recall we were discussing process capability analysis in the last two lectures. So, we have covered the various concepts and process capability indices. Now, in this lecture 26, I would like to share the Minitab application of process capability analysis. So, Minitab is a widely used software for conducting various kinds of statistical analysis, and this software is widely used for say doing the various kinds of analysis as a part of Six Sigma. So, I will just try to show some brief application of Minitab for conducting process capability analysis. So, once again I would like to remind you that a bad system will beat a good person every time. This is said by the renowned quality guru W. Edward Deming, and we must have a capable system, capable process, so that we do not unnecessarily take the corrective actions in the wrong direction. If you see the brief, then we talked about short term process capability, long term process capability, process capability indices, process capability concepts, process performance, and we had also seen that traditionally whatever we have seen DPMO, DPU and defect related measures, specific Six Sigma measures, they are different than process capability measures or indices, and we have seen that CP is basically indicates the potential of the process, CPK performance of the process, then you have CPU, CPL if you are targeting only one specification limit, and same way you have PP, PPK, PPU, PPL typically when you are considering a long horizon over which the process is observed, and for long term when you are conducting the process capability analysis. So, typically in this particular session which deals with the Minitab application, we will try to appreciate the steps to conduct process capability analysis, Minitab process capability analysis, examples, some demonstrations and like this. You will in fact find many video lectures also available 3 minutes to 10 minutes on YouTube that can also help you to appreciate the Minitab application. A good Minitab support is also available online, and you can see various examples. So, from those sources I have taken some of the examples to discuss with you, and we will appreciate how we can conduct the process capability analysis in Minitab. So, the steps goes like this. Step 1, go to file menu, click on open project and then load the required data. You may have a data in Excel sheet, you can import the Excel sheet or you can just copy paste the data, transfer the data in the new project file. Step 2, go to start menu, move to quality tools and then capability analysis or capability 6-pack. So, here you will find two options, capability analysis and second is capability 6-pack. We will see. So, this is a say commercial version, commercial software, and to suit and meet the requirements of the industry, they are offering two different kind of options, process capability analysis and process capability 6-pack analysis. Step 3, from the drop down menu select normal or non-normal analysis. At this stage we will only talk about normal. Subsequently, in the next lecture we will talk about non-normal process capability. Typically when my data is not normally distributed, then how to deal with this and how to conduct the analysis in Minitab. So, once you have selected the normal here in this case, and typically whether your distribution follows normal or non-normal. So, there are various ways and means. The simplest way is to look at your histogram, and that will at least give you some say insight that to what extent your data is symmetrically normally distributed or it is skewed on either side or it follows some other distribution. But there is normal probability plot, and when you plot your data on this, that will clearly give you the guidelines that yes, your data is normally distributed or not. So, we will see such kind of graphs also in this lecture. Step 4, click on non-normal or normal. For this lecture, as I mentioned, let it be normal. Enter the details required for conducting the capability analysis, click OK, and the moment you will click OK, Minitab will generate the various results outputs in a separate window. So, just see this and you will find it interesting that what are the say outputs your typical Minitab will generate when you are pressing OK and selecting process capability 6-pack analysis. 6-pack here means you will have 6 different results analysis presented and all are very much useful. If you see the first one, individual value eye chart, then this helps you to understand that whether there are some outliers or some of the say readings they are falling typically outside the upper control line or the lower control line. So, if you recall, I emphasize that in order to conduct your process capability analysis, your process must be in a state of statistical control, and if this particular graph for individual shows that it is not within control or some of the outliers are there, you can exclude the outlier, or first you can bring the process into the statistical control, so that whatever variation you observe, that is mainly within this control limit, and control limit statistically it is x bar plus or minus 3 sigma. So, you have the standard deviation value, this is your x bar, and when you put it as plus or minus 3 sigma, you get the typical upper control limit and the lower control limit. Now, here I can see that all the points are within, and I can have a fair assumption that my process is within the statistical control. Similar way, you also check for the range, because many times only individual observation cannot help me. We always talk about the center or location of the process and dispersion. So, variability I can capture through this particular moving range chart, and that will help me to understand that whether my readings for range are within the prescribed limit, that is the control limit, or some reading is going out. So, here you can see that one of the reading is going out, and if there is some assignable cause, special cause, you can at least remove this cause and bring your process into the statistical control. Then you have various observations and value plotted. So, this graph will just give you an idea that whether your observations they follow a random pattern or there is some kind of trend available. So, this is your 25 observation chart. Now, you can see here that you have the capability histogram and you have specification LSL 75, USL 105. So, this histogram, as you can see, will help you to appreciate that to what extent your assumption about normality is true and whether your data follows the normal distribution or not. If it is not, then you must go for the non-normal process capability analysis that we will discuss in the next class. Now, you can see the another one, that normal probability plot, and what you can see here, that you have the readings plotted here, all these readings in red dot, and suppose if I put a pencil or pen and if it covers all the readings on normal probability plot, then I would say that my readings they fall, or my observations they follow the normal distribution and my assumption about normality is true. You can have capability plot also. So, typically this is the end result that we are looking for. So, we have standard deviation, we have PP, we have PPK. On this side you can see standard deviation, CP and CPK, and you can easily make a conclusion that CP 1.12. So, technically it is greater than 1 and your process is capable. Similar way your CPK is 1.1. So, it is capable. When I look at the long term, this is my long term, then PPK and PP value are also greater than 1. So, I would not say it is a 6 sigma process, but because for that I need to be close to 2, but fine, technically greater than 1, it means my processes are capable in terms of performance, that is the spread, variability in terms of potential, PPK in terms of location or shifting the center value or the location. So, this is a very helpful analysis, and you can do it very easily in Minitab and interpret the results also. Now, the process which we follow in Minitab, I have already discussed the steps. So, you have statistics, the package, statistics, quality tools, capability 6 pack, and then normal, because my assumption is that it is normal, but definitely I would like to verify it through histogram as well as normal probability plot, and then I can open some file for getting the data input or for importing the file to my Minitab, and then I can conduct the Minitab 6 pack process capability analysis. So, I have shown here with a clear cut idea that this is the quality tool. Then once you will have here, you will have a drop down menu, you will have capability 6 pack, and then you select normal. So, it is a very simple and easy to follow procedure. Once you have done this, then you will have some data to be say inserted, and here you can see that there is single column, subgroup size is 1, and you need to enter this lower specification limit and upper specification limit. If you make mistake in say inserting the data, you will get asterisk. Asterisk means because of certain reason we could not conduct or software could not compute the value, and we have to be careful in inserting these values properly. So, this is the 6 pack analysis that you have seen, and we have discussed all the importance of all the 6 charts. Now, let us take the example and try to also solve it using the Minitab. So, calculate CP, CPL, CPU, CPK for the process which the data are given using the Minitab, and the process has subgroup size 5. So, each particular sample you have 5 units, it is a subgroup size, and 125 data points are there. You have USL upper specification limit 10.050, you have LSL 9.950, and you have mu 9.999. So, you have the data set, you can compute this, and you have sigma 0.0165. Now, as I mentioned, you can do 2 kinds of analysis. Number 1, you can go to stats, quality tools and capability 6 pack. So, it will give you 6 different outcome. Each one will help you to appreciate the data and the results and comment on the capability of your process. And second is through stat, quality tools and capability analysis. So, now we will see in the subsequent slides how to carry out this exercise. So, first let us say capability 6 pack. So, I have this particular window, this is step 1, import data in the worksheet of the Minitab application, and it is like Excel sheet only. Then you have capability 6 pack. So, from quality tool you go to capability 6 pack, I am elaborating it, and then you select the normal, then you put the data lower specification, upper specification, mean, standard deviation, and you press the OK. So, you will have 6 different charts of say graphs in front of you, and as I mentioned that these two will help you to understand whether my process is in control or not. This will help you to understand whether my data is randomly scattered or there is some pattern available. These two will help you to understand whether my data is normally distributed or not, and this will basically give you the value of your process capability short term, that is CPK, CP, and long term it is PPK, PP, and so on. Now, you can use the other option, that is simple quality tools capability analysis. So, once again import the data, then go to quality tools capability analysis and select the normal. Once this is done, once again you insert the values of your upper specification limit, lower specification limit, mean, and the standard deviation, and you have subgroup size 5. So, you will have the different analysis window or different graphs available, not like 6 pack where you are getting 6 different graphs in one window. Here it will generate first, let us say, process capability report for the data, and you can interpret very easily. This is the overall capability and this is the within capability. So, this is your long term, this is your short term, and you can see that PP value, PPL value, PPU, PPK, CPM as well as CP, all these are greater than 1. So, my process in this way is capable, but if you see the CPL, it is 0.99, so almost it is 1, but by chance if it is low, then it would say that I have little less capability when I look at the lower specification limit. Otherwise, my CPK, CPU, CPK more or less they are 1 or very close to 1. So, my process is capable. You will see another report, that is 95% confidence, and we will see in hypothesis testing, but many a times I want to conduct the confidence interval and want to see that my specific value of interest, does it fall into that confidence, statistical confidence interval or not. So, here you can see that this particular say graph has given you PP, but confidence interval for PP. It means this says that I am creating the confidence interval for 95%. So, please remember that statistics is basically based on the random phenomena, chance phenomena, and we try to take the sample and based on that we try to derive the inferences. So, we cannot be sure 100%, we have to make certain assumptions as well as we have to work with certain probability. So, here I say that 95% confidence I have that my PP value will fall in the range of 0.90, this is the one I am referring to, 1.16. So, I have 95% confidence in my result that my PP value will fall within this interval 95% of the time. Similar way, I would be interested to see that what is the confidence interval for PPK, and your PPK value is 1.01. But if you conduct the study number of times, you would find that for different subgroup or for different window of time, you will have different PPK value, but with 95% confidence I can say that my PPK value will fall within 0.88 to 1.13. So, this is something that is additional we can do in the process capability analysis, and we can create the confidence interval for various indices. So, just see the example here to strengthen your understanding, we want to assess the process capability for a production process that produces certain type of pipe, and typically the inside diameter is the CTQ, critical to quality, the quality characteristic in which I am interested, and that is of concern. So, specification limit for this is 7 plus or minus 0.025 centimeter, and there has been a consistent problem with meeting the specification limits. So, you are encountering the rejection, and now I want to see that whether my process is really capable or not. So, I took the random sample of 150 and I measured the inside diameter, and then I am trying to conduct the process capability analysis. So, you can see the steps, it is same as I mentioned, that you open the window, import the data or copy paste the data, say define the subgroup size, also enter the upper and lower specification limit, your standard deviation and mean value, and then you just try to click OK. If you want to conduct 6-pack analysis, choose that option. If you just want to go for process capability analysis, choose that option, and that would serve your purpose. So, this is the initial window where I have put the data. This is the pipe data you can see in first column, and then say second window I am going. So, capability analysis I am choosing, and that is normal. I am entering the data of LSL, USL, sigma, mu, and then I am also putting the target. So, we discussed CPM, and this particular target related indices is also called Taguchi capability index. Here I am specifying my target value, and with respect to that I want to conduct the analysis. So, once this is done, you can figure out that exactly what is happening with your process, and just see these values. You have PP 0.96, you have PPL 1.35, PPU 0.56, PPK 0.56 and CPM 0.61. So, excluding PPL, that is on the say lower side, all other values are less than 1, and clearly it indicates that your process has a problem. Now, if you see the PPL, this is quite good, 1.35. So, you have a comfortable zone towards lower specification limit, and if there is a need to readjust your center to the target or to some value, then you can little bit move towards the lower specification limit, and you can try to control the scrap which is increasing your cost. But this is a short term measure. For long term, obviously you have to correct the setting. If there are worn out parts, you have to replace them. If there is an issue with the operator skill, you have to train the operator, and likewise you have to take the long term actions also. So, this is 95% confidence, and same way you can see that what is the band, statistical confidence interval band, within which at 95% confidence my PP will fall, my PPK will fall, and so on. So, you have certain cautions, and I mentioned that if you do not enter the data properly, your Minitab output will show you the asterisk for some of the indices or some of the results, and this asterisk indicates that either reason number 1, only one specification limit. So, if you have entered only one specification limit but not both, then typically your PP and CP where USL minus LSL is required, that will show you the asterisk. Similar way, no target. So, if you do not enter a target for the analysis, what is your target value? CPM cannot be calculated because this is Taguchi process capability index, which demands that you should specify the target. If you are not interested in that kind of analysis, fine, you may not enter, but otherwise it will show you the asterisk. Two boundaries, if you select both specification limits as the boundaries, all capability statistics will have asterisk instead of values in the output. So, here you are creating the boundaries, selecting the boundaries as the specification limit, and you should only use a boundary when it is not possible for data to exceed that specification limit. Just to share the example, if you record downtime for a piece of equipment, a lower specification of 0 should be checked as a boundary because negative downtime is not possible. So, sometime to restrict my data within a particular range, negative downtime has no value, no importance, no significance. I would be interested to specify the boundary, but defining illogical boundary leads to say inability of the software to give you the result, and then it will show you the asterisk. So, to end this session, I would like to float couple of questions as think it. So, you have certain steps to follow in Minitab. Can you just summarize these steps once again? What is the capability 6-pack? Describe the features of this and how do you interpret the various outputs of 6-pack? What are the features of capability analysis in Minitab software? And we discussed already that can you distinguish the capability analysis simple and capability analysis 6-pack in Minitab software with couple of advantages and disadvantages over each other. So, I have highlighted here a couple of links from where I use the example, I took the example. You can also further refer it. You can refer the Minitab support, or you can put process capability analysis in Minitab in YouTube, and you will also get some of the good useful videos. So, conclusions about the capability analysis, we have devoted almost 3 lectures on process capability analysis, because a bad system will beat the right person every time. So, I must check that whether my process is capable or not, and if not, first correct the process, improve the capability instead of putting your effort or taking the action in the wrong direction. So, capability analysis reveals how well the manufacturing process meets the specifications and provides insight into how to improve the process and sustain the improvement, and Minitab typically is a popular tool which allows one to perform various statistical calculations such as normality test, non-normal process capability, and so on. So, thank you very much for your interest in learning this particular session on process capability analysis with the use of Minitab. I would advise that either you take the same data or some other data or some random data and put it in the say Minitab software new project file and conduct the Minitab analysis as advised. This will really help you to gain the confidence in the use of software. So, keep revising, keep introspecting, refer the suggested text and sources to strengthen your understanding, and be with me. Enjoy.